Hello class, this is section 221, Rational Functions Part 2. What we're really doing is solving rational equations. So our first step is going to be to remove the denominators on each side by multiplying each side by the needed factors. We want to make sure to watch for vertical asymptotes, extraneous solutions. So on the first one, I know you're thinking you could just do cross multiplication, and you could on this one. It's not going to work every single time. It would on this one. But really we want to think in terms of getting rid of our denominators. So if I multiply by a 3x minus 5, I get rid of the 3x minus 5, but I also have a denominator of x minus 2, so I want to multiply that as well. And it works because I'm allowed to multiply both sides of an equation by the same thing. So on the left, when I multiply, my 3x minus 5s would cancel. We're left with 20 times x minus 2, which I know is the same thing I would have gotten had I cross multiplied, right? That cross would have been 20 times x minus 2. On the other side, my x minus 2's are going to cancel. I'm left with 5 times 3x minus 5. Again, I know that's the same thing if I had done that cross multiplication. So the difference is we're going to have some later on where it doesn't work well if we're cross multiplying. When we cross multiply, it can make kind of a mess. So we want to have, it's good to have that tool in our toolbox, but we want to recognize what's really going on here. What's really going on here is that we're multiplying to get rid of our denominators, and it just happens to work out that that's our cross products. So on the left, I now have 20x minus 40. On the right, I have 15x minus 25. So at this point, I need to look at what I'm solving and come up with a plan. So I don't have any x squared, so it just means I need to get x's on one side, numbers on the other. So I always start with variables first. 15x is the smaller of the two, so I'm going to go ahead and subtract 15x on both sides. 20x minus 15x is a positive 5x minus 40 equals negative 25. Make sure you catch that negative there. Now I can just go through my solving steps for a two-step equation. I'm going to add 40 on both sides so that 5x equals 15. And then I'm going to divide both sides by 5, and x is 3. So next one, similar strategy to start out with. I want to clear all my denominators, so I'm going to multiply by the 2x plus 5 and the 11x plus 8 on both sides. And this is going to be another one where it just works out to be cross multiplication, because when I clear out the 2x plus 5s, now I have 1 times 11x plus 8. That's just 11x plus 8. On the other side, I would end up with x times 2x plus 5. And that's going to be 2x squared plus 5x. So now when I start to think about solving on this one, I'm recognizing that I have a quadratic. So quadratic means 0 on one side, everything on the other. So I would want to subtract my 11x and my 8 in order to have my 0 on that side, because I want my x squared to be positive. So 2x squared minus 6x minus 8. My first step for factoring would be to factor 2 out of all of them, 2, 6, 8. I can see they're all even. And then I can continue factoring. Figure out what multiplies to make negative 4, adds to make negative 3. So x minus 4 times x plus 1. When I do zero product property, I can ignore the 2 because it is just a constant. And so I will have 0 is equal to x minus 4, or 0 is equal to x plus 1. And then I do need to solve on those. As always, we should be checking to make sure we don't have any extraneous solutions, and we don't here. So the way I would do that is I'm really looking at these denominators, and if I put 3 back in for my x here, 3 minus 2 does not make a 0. 3 times 3 minus 5 does not make a 0. And 4 and negative 1 both work in my second problem as well. So you're just trying to make sure that your denominators don't equal 0. So this was kind of a fun problem, rational equations using rates. So a boat travels about 6 kilometers per hour in still water. If the boat is on a river that flows at a constant speed of r kilometers per hour, what is its speed, upstream and downstream? So let's think about that. So the way we come up with, let's see, our speed is, so if we're going upstream, upstream means we're going against the river, and so the river is slowing us down. And so that means I'm going to take my 6 and I'm going to subtract the r, because the r is going against us. Downstream means we're going with the river. So we would take our 6 kilometers per hour and we'd be adding the river's kilometers per hour, right? That's going to be pushing us along. So on one particular river, the boat can travel 4 kilometers upstream in the same amount of time it takes to travel 12 kilometers downstream. Write 2 equations to represent the amount of time it will take the boat to travel. Hint, T equals D over S. So what they're really getting that from is, let's think about our dirt equation, distance equals rate times time. And because the R stands for rate, which is our speed, but there's already an R in the problem, they're just calling it S instead. And then we're trying to think, how would we solve this equation for T? Well, if R and T are being multiplied and I want T to be by itself, then I have to divide by R. So my distance divided by my rate, which is really a speed, is going to equal my time. And I'm doing that for both of them. So for the first one, my time is going to equal, my upstream amount is 4 kilometers, and my upstream rate or speed is going to be 6 minus r. And that's what I had up here, right? Because in still water, I would travel at 6 kilometers per hour, but my boat is getting slowed down by the river, so I have to subtract r. So for downstream, I would write T equals, my downstream distance is 12, and that rate or speed is 6 plus r. We're increasing our speed because the river's pushing us along. So now it does say it takes the same amount of time. So that means we can take our expressions for time and we can now make them equal to each other and solve. So 4 over 6 minus r equals 12 over 6 plus r. And then we can think about multiplying by both denominators to cancel out denominators, or just doing cross products. But we're going to end up with 4 times the quantity 6 plus r equals 12 times the quantity 6 minus r. So go ahead and distribute. And then we want to think about what is our next step to get everything together. So I've got r's and numbers on both sides. So I would want to go ahead and add 12r on both sides. So negative 12 is smaller than 4. I always want to move my smaller variable. It's going to make it easier. So now I have 24 plus 16r equals 72. Subtract 24 on both sides. 16r is equal to 48. Divide by 16, and r equals 3. So the speed of the river is 3 kilometers per hour. Or river current, I'm not even sure what to call it. River speed sounds weird. Maybe river current is better. Question mark, not sure what to call that. So even though we started out with a rational expression on each side of the equation, multiplying each side by the product of the denominators, which was 6 plus r times 6 minus r. I totally didn't do that. That's what happened though, right? If I multiply by 6 plus r times 6 minus r, 6 plus r, 6 minus r, it's just clearing all of those denominators, and it's exactly what we came up with. Multiplying to get an equation with no variables and denominators is sometimes called clearing the denominators. All right. So the last 3 are a check your understanding. You should go ahead and try this on your own and then unpause, and we'll go over answers. So hopefully you've already tried these on your own. I know that cross products is just going to work for all of these. We will look at problems tomorrow where they don't work, okay? So on the first one, I would want to multiply both sides by both denominators, x plus 2 times x minus 1 on both sides. So this one, I have negative 6 times x minus 1. The other one would be a negative 12 times an x plus 2. So let's go ahead and distribute. Be really careful distributing these negatives. I want to get x's on one side, so I'm going to add 12x on both sides. And then 6x plus 6 equals negative 24. Subtract 6 on both sides. And x is a negative 5. And it does not make my denominator equal to 0, so we're good to go. Next one, I would multiply by both denominators again, x times x minus 2 on both sides. So on the left, the x minus 2's are gone. We are left with x times x plus 1. On the right, the x's are gone. We're left with x minus 3 times x plus 2. Or sorry, x minus 2. So go ahead and multiply those out. So x squared plus x squared minus 2x minus 3x plus 6. Be really careful distributing. I'm simplifying a little bit on the right. And now we always make a plan, right? At this point, we have to make a plan. And what I'm noticing is it looks like quadratics, but I have just an x squared, a 1x squared on both sides. So when I subtract 1x squared on both sides, my x squareds kind of like drop out of the equation, and then I don't have to worry about them. So now I just have x equals negative 5x plus 6. So let's go ahead and add 5x on both sides. So 6x equals 6. Divide by 6, x is equal to 1. And again, I don't need to worry about extraneous solutions. If I put 1 in for either of my denominators, let's remember 1 minus 2 is a negative 1. That's okay. It's not a 0. And if I put 1 over here, my denominator is just 1. So the numbers that I couldn't have would be like 2, because 2 minus 2 would make a 0. But I don't have that answer, so I'm fine. On the last one, I would want to, again, multiply both sides by the denominators, x times x plus 2 on both sides, to cancel all my denominators out. So here the x's cancel. So I have a 2 times an x minus 2 times an x plus 2. On the other side, I would have, let's see, an x times a 2x plus 4. So on the left, I want to distribute the 2 at the very end. I'm recognizing how this is an x minus 2 and an x plus 2. That's that difference of squares pattern. It's going to distribute out and make x squared minus 4. On the other side, I have 2x squared plus 4x. So let's distribute our 2 now. And then I am seeing that both sides, it's kind of like the last one, right, where both sides have a 2x squared. So I'm going to subtract 2x squared on both sides. And now I no longer have a quadratic. I have negative 8 is equal to 4x. Divide by 4. Negative 2 is equal to x. So let's go back and check our denominators again. Sure enough, this is a problem, right? This denominator is x plus 2. So if I substitute negative 2 in there for my x, that's going to give us a problem. Negative 2 plus 2 would make a 0. So x equals negative 2 is actually the vertical asymptote. It cannot be a solution. So I'm going to draw a line through it to show not equal. And this is actually extraneous. Negative 2 is extraneous. And it means here that I have no solution. So we're still solving today. We're really trying to get away from the idea of just cross multiplication and instead think about multiplying to get rid of factors, because that's what we're going to need for tomorrow. As always, if you need help, please make sure you ask.